Hello friends, today we're going to continue talking about factoring trinomials when the value of a is bigger than 1. So let me remind you, last unit we were doing multiplying polynomials and how we did this, a problem like this. We did it two separate ways, either using the distributive property, so 3x times 2x plus 3x times 1, plus 4 times 2x plus 4 times 1, or we use the box method, or the area model we called it. So we have 3x plus 4, 2x plus 1. So multiplying 3x and 2x is 6x to the second power. 3x times 1 is 3x. 4 times 2x is 8x. 4 times 1 is 4. Combining our like terms here, we end up with 6x squared plus 11x plus 4. Now, if we look here and we find the GCF of each row and each column, the GCF of 6x squared and 3x is 3x. The GCF of 8x and 4 is 4. The GCF of 6x squared and 8x is 2x. And the GCF of 3x and 4 is 1. So if you look here, the outer part is the GCF of the inner part. We're going to use that fact to help us factor these. So the first thing we're always going to do again is write down A, B, and C. A is 10, B is 17, C is 3. So A times C then is 30. So we're going to use our X. 30 goes on top, 17 on the bottom. These are both positive. Two numbers that are going to multiply to give me 30 and add to give me 17 is 15 and 2. Now, if A was equal to 1, we could almost be done and just write our final factors, but when A is bigger than 1, we have to also use a box. As we're using our box, we know that our term, our ax squared term, is always going to go here. So 10x squared is going to go here. Our C term is going to go here. So 3. And then we know that 17 got split up into 15 and 2. So these are going to be 15x and 2x. And then I just find the GCF then of each row in each column. If I look at 10x squared, that's the same as 2 times 5 times x times x. 15x is 3 times 5 times x. 2x is 1 times 2 times x. And then 3 is just 1 times 3. So now I just look for the GCF. If I'm looking at the GCF of 10x squared and 15x, it looks like I have both a 5 and an x in both of these. So the GCF of that row is 5x. If I go to my next row, 1 is the GCF of that, so plus 1. And now I'm going to do the same thing with my columns. If I look up and down here, the GCF of 10x squared and 2x is just 2x. And then the GCF of 15x and 3 is 3. So my final answer then, 5x plus 1, 2x plus 3. Let's look at another one. In this case, A is 2, B is 1. Remember, there's an imaginary 1 there. C is negative 21. So A times C then is negative 42. So looking at our x, we have negative 42 on top, positive 1 on the bottom. So I know I have a positive and a negative, and the positive number is bigger. So remember now in this case, I'm looking for two numbers that multiply to 42 and subtract to give me 1. And those two numbers would be positive 7 and negative 6. 7 times negative 6 is negative 42. 7 plus negative 6 is positive 1. So now putting them into my rectangle here. Again, our ax squared goes in the first box. Our c, negative 21, goes in the last box. And then we have 7x and negative 6x. Again, these numbers, 7x and negative 6x, is coming from my x here. So now finding the GCF of each of these. 2x squared is 1 times 2 times x times x. 7x is 1 times 7 times x. Negative 6x, negative 1 times 2 times 3 times x. Negative 21, negative 1 times 3 times 7. So now finding our GCFs. If I start with my first row, it looks like it's just a 1 and an x. So 1x, or just x. My second row, I have a negative 1 and a 3. Negative 1 times 3 is negative 3. Looking at my first column, it looks like I have 2 and x. So 2x. In my second column, I just have a 7, a positive 7. So my final answer then, x minus 3, or 1x minus 3, and 2x plus 7. All right, let's look at another one. The first thing I notice here is that these numbers are very large. And I know I can try to take a GCF out right away. If I look at 18, 18 is the same as 2 times 3 times 3. Negative 69 is the same as negative 1 times 3 times 23. And then 60 is 2 times 2 times 3 times 5. So I notice I can take a 3 out of all of these. So then I have 3. I should say this is the same as x times x, and this is the same as x. And I'm left with 6x squared plus negative 23x plus 20. So now I know my a is 6, my b is negative 23, and my c is 20. So a times c is 120. So now I'm looking for two numbers that are going to multiply to give me 120 and add to give me negative 23, which means I have two negative numbers here. Now that I have those negatives in, I can just look for two numbers that multiply to 120 and add to 23. And those two numbers are 15 and 8. So I know my 6x squared goes here, my 20 goes here, and then negative 15x and negative 8x. If I look at the GCF of each of these now, 6 is 2 times 3 times x times x. Negative 8x is negative 1 times 2 times 2 times 2 times x. Negative 15 is negative 1 times 3 times 5 times x. And then 20 is 2 times 2 times 5. So now looking for GCFs. If I look at my first row here, I have a 2 and an x for each of those. My second row, I have a 5. My first column, I have a 3 and an x. And then my second column, I have 2 2s, which is a 4. The thing is now, since we have negatives, I know I'm going to have subtraction in there somewhere. If I look at this and I want to know how do I multiply to negative 15x, it's 3 times negative 5, so that has to be a negative. Same up here with this negative 8x. 2 times negative 4 is going to give me negative 8x. So my final answer then, 2x minus 5, 3x minus 4. And then I still, of course, have the 3 on the outside that we took out as a GCF to begin with. Let's look at a few more here. A is 2, B is negative 1, C is negative 6, so A times C is negative 12. So now I'm looking for two numbers that multiply to give me negative 12 and add to give me negative 1. Since I'm multiplying to a negative, I know I have one positive and one negative. Since I'm adding to a negative, the negative number is bigger. So now that I know the signs, I can just look for two numbers that multiply to 12 and subtract to 4. I'm sorry, subtract to negative, or subtract to 1. Those numbers are 4 and 3. The 4 has to be negative. So we have 2x squared, we have negative 6, and then I have positive 3x and negative 4x. The boxes that you put the 3x and negative 4x in don't matter, they can be switched. Looking for GCFs now. 2x squared is 2 times 1 times x. Negative 4x is negative 1 times 2 times 2 times x. 3x is 1 times 3 times x. And negative 6x is negative 1 times 2 times 3. So now looking for our GCFs. If I start in my first row, I have a 2 and an x, so 2x. My second row, I have a 3, so 3. My first column, it looks like I just have a 1 and an x, so 1x or just x. And then my second column, I have a negative 1 and a 2, so negative 2. So we can check our work here. 1x times 2x is 2x squared. Negative 2 times 2x is negative 4x. 3 times 1x is 3x. 3 times negative 2 is negative 6. So I know I did it correctly. My final answer then, x minus 2, 2x plus 3. All right, one more example. In this case, A is 10, B is 3, C is negative 1. So A times C is negative 10. So we're looking then for two numbers that are going to multiply to give me negative 10 and add to give me 3. I know I have a positive and a negative. Once I have my signs, I can just look for two numbers that multiply to 10 and subtract to 3, since one's positive and one's negative. Those numbers are 5 and negative 2. So now drawing our box, we have 10x squared, negative 1, 5x, and 2x. So looking for GCFs, 2 times 5 times x, 1 times 5 times x, 1 times 2 times x, and negative 1 times 1. So here I have a 2 and an x in both of those. Here I just have a 1, so 1. And then looking at my columns, I have a 5 and an x in both of those. And then I have a 1 in both of these. But again, I notice now, oh, sorry, it looks like I forgot my negative 2x here, which means I have a negative 1 in both of these, which gives us a negative 1. So this is positive, and my final answer then, 2x plus 1, 5x, take away 1. All right, make sure you're using your note sheet so you know which signs go where and kind of the process to follow.